Hey guys, this is me Kong again from Posh Coaching Classes. How are you all doing today? Just wanted to continue with the same topic what we actually started. We are done with two topics, actually two videos. What I meant, it was about expected or important questions for your board exams, and we were covering class 10th mathematics. So we will be continuing the same topic again. I hope that you have practiced all those questions, and in case if you have any doubts, you can please send me a message. You can leave a comment and I will definitely reply to that as well. So let's start the set of some more questions which are very important for your board exams. So I hope that you will practice those as well. So let us start with our question number 1 for today. So our first question for today, it is about trigonometry, one of the very good questions, and at the same time it is one of your important topics and important chapters of your book. So the first question it says is, if cot theta is equal to 7 upon 8, evaluate 1 plus sine theta multiplied by 1 minus sine theta. Then we have in the denominator 1 plus cos theta multiplied by 1 minus cos theta. This is the first part, and then we have the second part. It says cot sphere theta. So to understand this question, we will just solve the question and we will use few identities and the table, the trigonometric table. So first of all, what is given? We have been given cot theta is equal to 7 upon 8. We know it for a fact that whenever there is trigonometry, we have a right angle triangle, and this is well-known fact here, a trick to remember. So I'm not going into this because I know you guys know this. So first of all, we have cot theta. This is sine, cos, tan, cosec, secant, cot. Cot is base upon perpendicular. So base upon perpendicular. So it means if theta is here, base is 7 and perpendicular is 8. So what is the first step what we have to actually concentrate on? The first step is find the hypotenuse. And how to find it? Very much easy. So in the given right angled triangle, using Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. Okay, so hypotenuse is the thing that we are searching for. Hypotenuse square. Base is 7, so we will put it as 7 square, and then we have perpendicular 8, so it is 8 square. Hypotenuse square, it means 7 multiplied by 7, it is 49. 8 multiplied by 8, 64. Hypotenuse square, if we add 49 and 64, 9, 6, 4, 10, 1, 11, it is 113, right? So that's what it is. It is, we have cot theta 7 upon 8, cot is base upon perpendicular, so base perpendicular 7, 8, base and perpendicular 7 square, 8 square, and then hypotenuse is equal to, this square goes that side, it is 113. Okay, now this was not the question, we just searched hypotenuse. Now I need to know what is sine theta, then what is cos theta as well. So I will search for sine theta. Sine theta is perpendicular upon hypotenuse. And what does that mean? Perpendicular is 8 and hypotenuse is under root 113. And then I have cos theta. Cos theta is base upon hypotenuse. So base upon hypotenuse. Base is 7 and hypotenuse is under root 113. Mind you, this is a very important question, so please pay attention. So we have sine theta 8 upon under root 113, then we have cos theta 7 upon under root 113. What next? The next thing what we are going to do is we will substitute these values. First of all, we'll take the first one. It was 1 plus sine theta, so bracket 1 plus sine theta is 8 upon under root 113. Then it says 1 minus sine theta, it is 1 minus 8 upon under root 113 whole divided by, then we have 1 plus cos theta, it is 1 plus cos theta is 7 upon under root 113, and then 1 minus cos theta, that is 7 upon under root 113. Is that clear? Now I can see there is one identity that we can use. It is a plus b into a minus b. So I'll just write it here. We know that a plus b multiplied by a minus b is a square minus b square. This is the identity which I am going to use here. So it means a is 1 and b is 8 upon under root 113. So it is 1 square minus 8 upon under root 113 whole square. Similarly, this is a plus b multiplied by a minus b, that is 1 square minus 7 upon under root 113 whole square. Right? Now 1 square is 1 minus 8 into 8 is 64 under root 113, and then we have a square. Square and under root goes, it is 113. And then we have 1 minus 7 into 7, 49. Similarly 113. Now what we are going to do, we'll take the LCM. It is 113, it is 113 here minus 64. Then we have the LCM again, 113. 113 into 1 is 113 minus 49. Is that clear? Now I'll just take this off. Now what does it say? It says 113 minus 64, 94. It means 49 upon 113. Then I have 113 minus 49, that is 64 upon 113. What does this become? 49 upon 113 multiplied by this will just get reciprocated. It is 113 upon 64. 113 and 113 gone. It is 49 upon 64. So the first one, this is the answer, right? We are not finished yet. We have one more step or one more part here, so we'll just finish that off as well. It's not that big. Now what does it say? We have to find cot theta whole square. We have been given cot theta is equal to 7 upon 8. So we have to find cot square theta, that is 7 upon 8 square. It means 7 into 7, 49, 8 into 8, 64. So the answers are identical, but the parts are different. This is the second part and this one was the first part. I hope you understood this. Very, very important question. So this was the first question. Let's move on to question number 2. All right, question number 2, what we have is, it says if 3 cot A is equal to 4, check whether 1 minus tan square A whole divided by 1 plus tan square A is equal to cos square A minus sine square A or not. So there is a possibility that it is not equal as well. So we'll just see and check. We'll just check here. So solution, we'll take the given thing. What is given? It is 3 cot A is equal to 4. So cot A is equal to 4 upon 3. Now we know cot, sine, cos, tan, cosec, sec, cot, it is based upon perpendicular. So if I just draw a small figure, if this is A then we have base upon perpendicular. Base is 4 and perpendicular is 3. So the first thing, we know it, we need to find the hypotenuse. So using Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. So what does it say? Hypotenuse, we have to search, then base is 4 and perpendicular is 3. Hypotenuse remains the same because we don't know what it is. It is 4 into 4, 16, then we have 3 into 3, 9. Hypotenuse square, 16 and 9, it is 25. Hypotenuse, this square goes that side, this becomes 5 square, so hypotenuse is 5. Right, so the first thing is done. So we have hypotenuse equal to 5. Now this part is left hand side, so I'm taking left hand side. It is 1 minus tan square, 1 minus tan. Tan is perpendicular upon base, so we have perpendicular equals to 3 and base 4. So it is 3 upon 4 square, and then I have 1 plus tan square, again 3 upon 4 whole square. We'll just solve this first. What does this become? It is 1 minus 9 upon 16, 1 plus 9 upon 16. Then we'll take 16 LCM, it is 16 minus 9, and then 16 plus 9 upon 16. Now 16 minus 9, it is 7 upon 16 whole divided by 25 upon 16. Then it is 7 upon 16 multiplied by reciprocating 16 upon 25, 16 gone, so it is 7 upon 25. So this is our left hand side. Now we will talk about the right hand side, taking RHS, cos square A. So cos is base upon hypotenuse. So base is 4 upon hypotenuse is 5 square minus sine. Sine is perpendicular upon hypotenuse. So perpendicular is 3 and hypotenuse is 5 square. This becomes 16 upon 25, 9 upon 25. We'll take the LCM 25. 16 minus 9, that is 7 upon 25. If you see this and this, means left hand side is equal to right hand side. I'll just put it here, LHS is equal to RHS, hence proved. Right, I hope you got this one. Very easy and very important as well. So what was the thing? We had cot A is equal to 4 upon 3. We just searched for the hypotenuse, and after that we just put all the values, whatever the things were given, tan, cos and sine. We just used and substituted the values, and we got left hand side equals to right hand side. I hope this one is clear. So I will just go for the next question. The next question what we have, it is, if A, B and C are the interior angles of a triangle ABC, then show that sine B plus C whole divided by 2 is equal to cos A upon 2. So very good question. Now what we will do, obviously we have to take a triangle, so we'll say we know that sum of 3 angles of a triangle is equal to 180 degrees. What does it mean? It means angle A plus angle B plus angle C is equal to 180 degrees. Now I can see there's a B and C one side, and then we have A on the other side. So I'll just do one thing. I'll keep B and C here, and I will take angle A to that side. It becomes minus angle A. Clear? Now I can see there's a divided by 2 here, so I'll say dividing both sides by 2, it becomes angle B plus angle C upon 2, 180 degrees minus angle A upon 2. Now this thing is exactly what I require, so I'll just keep it the same way, and then this thing can be written as this as well. So it is angle B plus angle C upon 2. This is 90 degrees minus angle A upon 2. Right? Now, what is missing? There is a sign missing. So, taking sine on both sides, it becomes sine angle B plus angle C upon 2 and sine 90 degree minus angle A upon 2. This is exactly the same what I want, so I'll just keep it the way it is. Sine angle B angle C upon 2. I know it for a fact that sine 90 minus theta is equal to cos theta. This is an identity. So sine 90 minus theta, theta is angle A upon 2, is cos 90, cos theta I mean. Cos theta is angle A upon 2. This is what is required. So sine B plus C upon 2 is equal to cos A upon 2. This proves the answer. Okay, so this is the question. I hope you understood this. It is what I did. Sum of 3 angles, 180 degree, angle A plus B plus C, 180 degree. I took angle A to that side, divided both sides by 2, then took sine, got this one, and ultimately got the other side as well. I hope you understood. Let's take this off and take the next question. The next question, again trigonometry, and very important question. I know you might have seen this question, and it is quite a tricky one, but very easy if you know the identities. So what the question is, it says express the trigonometric ratio sin A, sec A and tan A in terms of cot A. What does it mean? It means that you have to find the solutions for all the 3 in terms of cot A. Means all the 3, the answers of all the 3 should have cot in it. Alright, so we'll just try and use the identities. So let's take the first identity. I will say we know that sec square A is equal to 1 plus tan square A. This is one identity. Now I need to find sec. It is there. So sec A, I'll just keep it like this. This is sec square A is equal to 1 plus. I know that tan is 1 upon cot. So I'll write 1 upon cot A whole square. So what does this become? Sec square A is equal to 1 plus 1 multiplied by 1 remains the same, and then we have cot square A. Sec square A is equal to, if I take the LCM, cot square A multiplied by 1, it is cot square A plus 1. Now sec A is equal to under root cot square A plus 1 whole divided by cot square A. Right, still I have one more thing that I can do here. It is sec A is equal to under root 1 plus cot square A upon we have under root cot square A, right? This thing and this thing gone. I have sec A is equal to under root 1 plus cot square A upon cot A. This is sec A in terms of cot A, right? Then I have one more, it says tan A. Tan A is simple, I know tan is 1 upon cot A. Done this as well. Now I have sine, so I will use one more identity. I will say we know that cosec square A is equal to 1 plus cot square A. Okay, so I need to find sine, but I am using an identity and it says cosec square A is equal to 1 plus cot square A. But I know for a fact that cosec is 1 upon sine square A. Clear? Now, I need to find sine A. So what I will do, I will just I'll cross multiply both the things. It is sine square A into 1 plus cot square A is equal to 1 multiplied by 1, 1. Then sine square A is equal to 1 upon 1 plus cot square A. Right? Still, sine square A is there, so I need to search for the sine A. Sine A will be equal to under root, I will take under root that side, it is 1 upon 1 plus cot square A, and then sine A is equal to under root 1 upon under root 1 plus cot square A. If I take 1 as 1 square, it is one and the same thing, so I'll just take this off. Sine A is equal to 1 upon under root 1 plus cot square A. Have I got all the ones? Sine A, this is the one. Then sec A, I have got the answer, and tan A as well. It's a very, very important question. I'll just repeat it one more time. I had a question that I need to find the answers of sine A, sec A, and tan A in terms of cot A. So what I did, I used one of the identities. The identity is sec A is equal to 1 plus tan square A. I just took the same thing, and I know that tan is equal to 1 upon cot, so I just used it in the place of tan because I need the answer in the cot form. So it is 1 upon cot A is then whole square, sec square A is equal to 1 plus 1 upon cot square A, then the simple math, and I got the answer for sec. This is the answer. And then tan, it is as simple as that. Tan A is 1 upon cot A. Afterwards, I used one more identity. The identity is cosec square A is equal to 1 plus cot square A. I took it, and then I know that cosec is equal to 1 upon sine A. I used that here, then the simple math, and I got the answer of sine A as well. Hope this is clear. It finishes one more question. Let's go to the other one. Next question, again trigonometry, important question. So what does it say? It says prove that sine theta minus twice sine cube theta whole divided by 2 cos cube theta minus cos theta should be equal to tan theta. That's what we need to prove. Let's see what we can do. So in these type of questions, we need to take either of the sides. So taking LHS, what do I have? I have sine theta minus twice sine cube theta. Very clearly I can see sine theta can be taken common. So what does it become? 1 minus twice sine square theta. And the bottom, what do we have? We have cos theta common. So I'll take cos theta twice cos square theta minus 1. One thing I can see very clearly here itself, that I need the answer has to be tan theta. So I know that tan theta is equal to sine theta upon cos theta. That means this and this has to get cancelled come what may. So let's see, sine theta 1 minus twice sine square theta whole divided by cos theta twice. I know, if you must be knowing this, sine square theta plus cos square theta is equal to 1. What I need is cos square theta. So cos square theta is 1 minus sine square theta. So that's what I will put here. It is 1 minus sine square theta, then I have minus 1. Now sine theta 1 minus twice sine square theta whole divided by cos theta, it becomes 2 minus twice sine square theta minus 1. Now this thing is still the same, sine theta 1 minus twice sine square theta whole divided by cos theta, then 2 we have subtracted with 1, so 2 minus 1 is 1 minus twice sine square theta, both are identical, just cut them off. So what do we have? Sine theta upon cos theta, which is tan theta. Therefore LHS is equal to RHS. Simple, very simple. We took the left hand side, we used the identity, and the question is done, right? Very simple. Let's move to another one quickly. So next one, it says prove that 1 plus tan square A whole divided by 1 plus cos square A is equal to 1 minus tan A whole divided by 1 minus cot A whole square, and then is again equal to tan square A. So don't get confused here. We can take two things, and if both the things are equal to the third one, it means we have proved the question. So let us take this one first. It says 1 plus tan square A. So what I can write is, I can write 1 plus sine square A upon cos square A whole divided by 1 plus cot square A is equal to cos square A upon sine square A. Clear? Okay. Now I'll take the LCM. It is cos square A. Cos square A into 1 is cos square A plus sine square A. Then I have LCM sine square A. Sine square A into 1 is sine square A plus cos square A. Right? I know for a fact, we know that sine square A plus cos square A is equal to 1. So sine square A plus cos square A is equal to 1. So I'll write 1 upon cos square A. Then sine square A plus cos square A, again 1 upon sine square A. Right? Now what does it become? It becomes 1 upon cos square A into, then reciprocating sine square A upon 1. So it is sine square A upon cos square A, that is sine square A multiplied by 1 sine square A, then cos square A, which is equal to tan square A. Right? So this part is equal to this. So till now we are fine. So now I will take this one. I hope you understood this. Very simple. So I'll take the other one now. So the other one is 1 minus tan A upon 1 minus cot A. Now what to do? We'll do the same thing. 1 minus sine A upon cos A whole divided by 1 minus cos A upon sine A whole square. Now taking the LCM, this is cos A into 1 is cos A minus sin A. Then I have sin A as LCM, sin A multiplied by 1 sin A minus cos A, right? Scale. Now what do we have? We have cos A minus sin A whole divided by cos A multiplied by sin A. Then I have sin A minus cos A whole square. Now I cannot cancel out anything because here I have cos A minus sin A, here I have sin A minus cos A. One thing I can do, I can take minus out, it becomes sin A minus cos A upon cos A multiplied by sin A whole divided by sin A cos A. Don't get confused here. If I multiply minus with sin A, it becomes minus sin A, then minus into minus, that becomes plus, then cos A. What is the reason behind this? Because now I can cancel this and this. And what is left? It is minus sin A upon cos A whole square. If I do the squaring, minus into minus is plus, sin into sin A into sin A is sin square A upon cos square A, which is again equal to tan square A. So proved. I hope you got this. This part was the simple one, sin A upon cos A, tan A, then we have cos A upon sin A, which is cot A whole square, taking the LCM and here reciprocating. The only tricky part is this. What I did, I just took minus common, and after taking minus common I could cancel these two, and after that minus, it was just because there was a square, so it will just go. So minus into minus plus, and then we have sin square A upon cos square A, that is tan square A. Right, so I hope you are clear with this question as well. You can just practice all these questions. Today's questions were mostly on trigonometry because it's one of the important topics of your entire book. Now I will have one more video on this particular topic, that is expected and important questions on for your exam. So there will be one more last video. If you do all these questions, I promise you that you will get good scores, because these are some of the expected questions that you will see and you will come across in your exam. So I hope that you all do these questions, and as I said earlier as well, if there is any doubt, you can leave a comment and I will definitely revert back. So that's all for today. I hope you enjoyed the session and there was something that you could learn. So please do subscribe to our channel, that is Posh Coaching Classes. Ask all your friends, and please do share this video, especially these 3 videos and the one which is coming soon. So please do share these videos with your friends who are with you in your schools or in your coaching classes, so that they can get benefited as well. So thank you so much. That is all for today. Saying adios. Thank you.